Hi, this is Ms. Goodman, and I'm going to present 3 problems which use the negative exponent rule. These problems come from the second Module 3 homework assignment. Question 9. 2 times x raised to the power of negative 2. You're asked in this problem to rewrite this expression using a positive index, a positive exponent. Now, the negative exponent rule says that any base raised to a negative power is the same as 1 over that base raised to a positive power. In other words, if you want to make the exponent positive, you take the reciprocal of the base, and it changes to the opposite sign. So let's look again at question 9. You have to be clear, what is the base? Since there are no parentheses around the 2x, we know that the base is only x, does not include the 2. So only the x is raised to the power of negative 2. So only the x has a negative exponent. To make it positive, we simply take the reciprocal. We bring this x in the denominator position below the 2, and the exponent becomes positive. And that's our answer. Question 10. We're asked here to simplify 5 times p squared times q raised to the negative 4 times 7 times p raised to the negative 4 times q to the 6th power. Okay, well, you know that you can multiply your numbers together. So 5 times 7 is 35. And since we're multiplying, we know here that we're going to apply the product rule. The product rule is one of the laws of exponents. And the product rule applies to like bases. We have like bases right here, p squared, and then we have that p to the negative 4. So I'm going to write those together. Okay, the p squared and the p to the negative 4. Then I'm going to write the q to the negative 4 and the q to the 6th power. Okay, the order in which I write these factors, remember, doesn't matter because multiplication is commutative. The order doesn't matter. But this way I can see where my like bases are and apply the product rule, which says that when you multiply like bases, you add the exponents. So we're going to add 2 plus the negative 4, and then here we're going to go negative 4 plus the 6. And this simplifies to 35 p to the negative 2, because 2 minus 4 is negative 2. 4 minus 2 is 2, but the bigger absolute value is negative, so the result is negative 2. Okay, it's sign numbers. And then here we have q to the negative 4 plus 6 is the same as 6 minus 4, which is 2. So we have 35 p raised to the negative 2 power times q squared. Now one of these exponents is still negative. So we apply the negative exponent rule, which says if we take the reciprocal of p to the negative 2, the exponent will become positive. So on the top, we keep the 35q squared because they have all positive exponents. But the p to the negative 2 goes to the denominator position and its exponent becomes positive. And that's our answer. We cannot apply the quotient rule here because q and p are not like bases. They represent different values. So we just leave it. That's as simplified as it goes. One more problem. This is question number 11. Four times p raised to the power of 9 times q raised to the power of negative 2 over 2 times p to the negative 4 times q to the power of 8. Okay, so we have negative exponents and we have like bases, p and q and q, and we're dividing those like bases, so we know we're going to apply the quotient rule. We have to simplify this as far as it goes using the laws of exponents, and we have to have all positive exponents in the end. So first let's do the numbers. 4 divided by 2, that goes in evenly. 2 goes evenly into 4. 4 divided by 2 is 2. Okay, and then we have our like bases, p and p, and they're being divided. Quotient rule. The result of division is a quotient. The quotient rule says when you're dividing like bases, subtract the exponents. And be very careful here, we have a minus minus. Minus from the quotient rule and a minus from the exponent. Multiplied by q to the minus 2 minus 8. That minus is because of the quotient rule. Simplifying the signs here, 2 times p to the 9 plus 4 times q to the minus 2 minus 8. How many negatives is that? You have 2 negatives, 8 more negatives, that's 10 negatives altogether. Negative 10. Okay, you're going 2 in the negative direction and 8 more in the negative direction. Altogether you've gone 10 in the negative direction. 2 times p, 9 plus 4 is 13. Q to the minus 10. Almost done, one more step. The exponent on the q is negative and we need it to be positive. So we keep the, erase that. We keep the 2 times p to the 13 in the numerator position because they have both positive exponents. But the q has a negative exponent, so it goes down in the denominator position and its exponent becomes positive, and that's our answer.